Another important topic to review before you begin AP Calculus is the unit circle. I'm sure that you've seen the unit circle in pre-calculus before, but this is really one thing that I use all the time in AP Calculus. So I want to make sure that you have reviewed it before we continue. It says you will need to know the unit circle cold. I will quiz you on the unit circle early in the semester. Here is a blank unit circle. Fill in the radian measures, the degree measures, and the x and y coordinates. All right, so the unit circle is based on special right triangles, so 30, 60, 90 triangles and 45, 45, 90 triangles. All right, the 30, 60, 90 triangle that I'm going to draw in first is right here in the first quadrant. It's called the unit circle because it has radius 1. So that means I'm going to have 1 there. I have 30 degrees, 60 degrees, and 90 degrees. Now, if you remember your 30, 60, 90 triangles, we usually did u across from the 30, then across from the 60 was u times the square root of 3, or you can use n or whatever you want, and then 2u. Okay, so if 2u is equal to 1, that means u is equal to 1/2, right? And this next one is u times square root of 3, so it's going to be 1/2 times square root of 3, so it's square root of 3 over 2. So that means we go out along the x-axis, square root of 3 over 2, and we go up 1/2. So the coordinates are over square root of 3 over 2, up 1/2. So that point right there is square root of 3 over 2, comma 1/2. All right, let's continue this for our 45, 45, 90 triangle. Our 45, 45, 90 triangle, I'm going to draw in right here. So again, my hypotenuse is 1, because it's a unit circle, the radius is 1. So if I have u, and u times the square root of 2, u times the square root of 2 is equal to 1. So if I'm solving for u, I have 1 over the square root of 2, which we know is, if you rationalize, so multiply by square root of 2 over square root of 2, you get square root of 2 all over 2. So that means you go out square root of 2 over 2 and up square root of 2 over 2. So these coordinates are square root of 2 over 2, square root of 2 over 2. Okay. Now again, I have a 30, 60, 90 triangle, but now my 30, 60, 90 triangle is right here. So 60 degrees and 30 degrees. My hypotenuse is 1. Again, your hypotenuse is 2u. Across from the 30 is the smallest length, u. And across from the 60 is u times the square root of 3. So if 2u is equal to 1, that means u is 1/2. So now my 1/2 is my x value, my x coordinate. And my square root of 3 over 2 is the y coordinate. So basically the point we had before just switched x and y values. So now it's 1/2 comma square root of 3 over 2. Okay. Now this is basically all you need to know for the unit circle because the unit circle is symmetric. So if I was going to draw in some different values, the one that goes out here, I know my radius is 1, so it's 1, 0. The one at the top is 0, 1. Okay, so we got all those. Now let's use symmetry. Now remember, these are x and y coordinates. So over here, I should have a negative and a positive. So x is negative, y is positive. And it's symmetric. So I'm going to look at 1/2 square root of 3 over 2. And over on the other side, I'm going to have negative 1/2 positive square root of 3 over 2. And then you continue to fill in all of the values. Okay. The big thing that I remember when I'm drawing the unit circle is that I always think square root of 3 over 2 is bigger than 1/2, right? Square root of 3 is bigger than 1. So I always think, do I go out further along the x and up less along the y? In that case, the x value is bigger, so square root of 3 over 2, and the y value is smaller, 1/2. So that's a big thing that will help us. All right, so fill in the remaining unit circle with your x and y values. Now your degrees were just, what we had before. This was 30 degrees, so right here I have 30. This one was 45, 60, 90 degrees. Okay, now think about it. If this was 90 and the one over here was 60, that's a distance of 30 degrees, so this one's going to be 120. All right, now this one only differed, 60 and 45 only differed by 15, right? So you can figure it out that way, or you could say, I'm going to add 45 degrees to 90, so I get 135. I'm going to add 60 degrees to 90, so I get 150, and so on, 180. Okay, finish all of your degrees going all the way around. Now at the starting point, it's 0 degrees, but it's also 360 degrees. 2 pi would be 360 degrees all the way around. Okay, now your radian measurements. Radian measurements are the only things that are used in AP Calculus, so it's very, very important that you know these. If you've been using degrees before, you're not going to really be able to use degrees. Rarely is there a problem that uses degrees in AP Calc. 0. All right, so this is 0 radians. All radians is the arc length. So, if you have radius 1, the circumference is 2 pi r, which is just 2 pi. So going all the way around my circle, that would be 2 pi. Going halfway around, I'd get pi. Going a fourth of the way around, I'd get pi over 2. See how this is working? Going an eighth of the way around, I get pi divided by 4, and so on. Now think about 30 degrees. If I was at 30 degrees, we know 30 out of 360, well, that's just 1 out of 12, right? Now you can convert that to radians by saying that's 1/12 of the whole 2 pi. So you get pi over 6. But I think the easiest way to think of it is to say, okay, pi would be going all the way to 180 degrees. So pi's there. What fraction of 180 is 30? 30 is 1/6 of 180, so it's pi over 6. Does it make sense? So if I had 60 degrees, that's pi over 3, and so on. So fill in the rest of your pi's as well. Okay, let's go ahead and see how this is useful in solving. So solving trig equations. This is why I want you to know the unit circle cold. Okay, so if I have sine of x equals 1/2, let's think about what that means. On your unit circle, the y values are sine. So sine is the y value on unit circle. Okay, cosine is the x value. So what you're looking for is all the y values that equal 1/2. So let's think about it. On my unit circle, you're saying, when is my height, my y value, equal to positive 1/2? So it'd be there and there. That would be going out further along the x, the square root of 3 over 2, up 1/2. And you could also have negative square root of 3 over 2, up positive 1/2. Y is positive 1/2. So that'd be right there. So think about it. If I wanted the radian measure, the radian measure is pi over 6. So pi over 6 over here. And this radian measure, well, it was almost at pi, but it was pi over 6 away from it. So if you had pi minus pi over 6, think of it, 6 over 6 pi minus pi over 6. It's 5 pi over 6. So your two answers in this case are x equals pi over 6 and 5 pi over 6. Notice I asked for you to find all solutions on 0 to 2 pi, not including 2 pi. All right, number 2 is a tricky one. Everybody always messes up on ones like number 2. Make sure you do not divide by cosine on both sides because that gets rid of a solution. Just like if I gave you x squared minus x equals 0, or sorry, let me write it another way first. If I gave you x squared equals x, you can't just divide by x. If you divide it by x, you get x equals 1, right? But you guys learned from algebra that you need to subtract your value over and factor. You actually have 2 solutions since it's degree 2, x equals 0 and x equals 1. So you would have lost that solution, x equals 0. Same thing in this case in number 2. So we don't want to lose that solution, so I'm going to pull over my cosine of x, and I'm going to factor. Okay, so then I could have cosine of x equals 0, or cosine of x minus 1 equals 0. In other words, cosine of x equals 1. So you're saying on your unit circle, where is your x value equal to 0? So x equals 0 here and here. And then you're also saying, where is your x value equal to 1? So that one happens right there. So there are 3 different locations. So x equals 0 at pi over 2 and 3 pi over 2. And cosine of x equals 1, so your x value is 1 at 0. So remember, you could also say 2 pi, but we have a parenthesis there, so we don't include 2 pi. So those are your 3 solutions. All right, make sure that you factor on number 4. You're also going to need a factor on number 5, which is kind of hard to see. But you need 2 sine of x and 1 sine of x to multiply to be the 2 sine squared x. You need a negative 1 and a positive 1. So let's think about where they'd have to go. My outer is negative 2 sine of x. My inner is negative 1 sine of x. How do I combine 2 and 1 to get 1? So I need positive 2 and negative 1. So it's like that. All right, set both equal to 0 and solve. So I get sine of x equals add the 1, divide by 2. Sine of x equals subtract the 1, negative 1. So when is sine equal to 1/2? Well, we did that before. That was number 1. So we know that's at pi over 6 and 5 pi over 6. And then when is sine of x equal to negative 1? So when is the y value on your unit circle equal to negative 1? Well, y is negative 1 down here. That's at 3 pi over 2. So 3 pi over 2, pi over 6, and 5 pi over 6 are your answers. Okay, same things for these other ones. You're going to need to factor. Number 9 looks kind of tricky. Number 9, you can factor into sine x plus cosine of x times sine of x minus cosine of x equals 0. Okay, so you have sine of x plus cosine of x equals 0, and sine of x minus cosine of x equals 0. Okay, and this seems kind of intimidating when you first see it, but let's think about it logically. You're saying, when is sine of x equal to negative cosine of x? And when is sine of x equal to cosine of x? Okay, so let's draw unit circles for both. So you're saying, when is your y value equal to the negative of the x value on your coordinates? Okay, that means x and y have to have the same value, but opposite signs. So it'd be here, because that's square root of 2 over 2, well, negative, and positive square root of 2 over 2. And it's also down here. Oh, not down there. Down here, right? Negative, negative. No, I was right the first time. Positive, negative, right? So I have positive square root of 2, negative square root of 2. Okay, now on the other one, it's saying, when are your x and y values exactly the same things? So when you look at the coordinates of your unit circle, when are x and y equal? here, and here. Okay, so what are those values? That would be when you have radian measure. So I went almost all the way to pi, but I was pi over 4 away from it. So what is pi minus pi over 4? Well, 1 minus 1/4 is 3/4, right? So it's 3 pi over 4. And the other one is almost 2 pi. So I would think of just adding a full pi to your 3 pi over 4, so it'd be 7 pi over 4. Or you could think of it as being 1/4 away from 2, right? Okay, now these other ones are pi over 4, and then you're going pi over 4 more than pi, so 5 pi over 4. So you have 4 solutions. Okay, and that's it. Okay, so make sure that you know the unit circle cold for AP Calculus.